Welcome to Notebook 41, Structured Output. In this notebook, we're going to introduce using large language models to generate structured output and explore some basic methods for generating data out of the LLM in batch for downstream use. By the time you complete this notebook, you'll learn about the value of getting LLMs to generate structured output. You'll be able to prompt your model to generate structured output, and you will be able to use the chat model to batch process inputs into structured data. We'll begin with our imports. We have one new import for this notebook, namely the simple JSON output parser, which we'll be looking at below. We'll be leveraging the same large language model instance we have been throughout the workshop. Okay, so a very common task we would like LLMs to perform is to generate outputs in a highly structured format. These formats could be as common as JSON or a Python list or some custom structure unique to our needs like a custom report or document structure, just to name a few examples. We've explored custom formatting in a lightweight way. For example, when we were prompting our model to give us the location of a city using a very specific format. But it's worth mentioning here that when we talk about highly structured format, what we mean by this typically is code, right? Code, as you know, is very precise. The syntax of code is very strictly defined. So when we want a large language model to generate data in a structure that can be consumed by code, then we have to take extra special care because, as you know, a single missed character or additional white space or you name it can make it so that what could be working code is not actually working code. And that makes all the difference in our programs. Okay, so over time, as LLMs have gotten better, their ability to generate highly structured data has definitely improved drastically, even for relatively small large language models like the 8 billion parameter model we're using today. But still, and especially when generating structures with highly specific formatting requirements like JSON or code of any type for that matter, it can take some prompt engineering efforts to get the model to consistently produce what we need. So let's begin this section with work on a very common task, which is getting the model to produce structured JSON. JSON is a great structure in the context of many applications, as it can be used in many downstream tasks either directly or by converting the JSON to a large variety of other usable formats like Python dictionaries, data frames, etc. Right? So let's start with a simple Python, trying to create a simple a simple JSON object. And in the spirit of iterative prompt development, let's start simply by engineering a prompt, instructing the model to construct a JSON object. For our example, we're going to ask the model to create a simple JSON object representing the details about the city of Santa Clara. So here's our prompt. We're using a multi-line prompt. We're saying make a JSON object representing the city Santa Clara. It should have fields for the name of the city and the country the city is located in. So let's just give that a go. Okay, so we got back some conversational text. Here is a JSON object, and this additional note down here as well. From the model that's not desired. But the good news that within this response, kind of in two different cases actually, we have a very good looking, well formatted JSON object, which is great. And again, I guess I've been doing this for just a few years now, so I've got to experience how much better large language models have gotten just in the last couple years. Probably by the time you see this, they've gotten even better. But LLMs are rapidly getting much better at generating structured output. And you might be interested to know that even like several months or a year ago, using Llama 3.1's predecessor, Llama 2, right? Getting back such a nice response like this with such a simple prompt on an 8B model, like this just wasn't going to happen, right? So I have full expectation that the models are going to continue to get even better at this, including models that are smaller and smaller in size. Okay, so that comment aside, let's continue to iterate on our prompt to see if we can get rid of the conversational text. So here we'll include in our prompt, only return the JSON, never return non-JSON text. If we take a look at this, this is getting much closer to what we want. In fact, if we were looking for Markdown that rendered as JSON, then this would be exactly what we needed. But we want the actual JSON, so let's see if we can get rid of the backticks as well. We'll iterate on our prompt again to say never return non-JSON text, including backtick wrappers around the JSON. And with this prompt, you can see, at least eyeballing it, this looks to be like what we want. But just to sanity check our work, right? One of the main ideas in working with structured data is that we can use it directly in code. So let's try to do that with the model's response. Here we're going to take the same prompt and invoke the LLM, but we're going to store the response in a variable called JSON city. We're going to import Python's JSON library, and we're going to attempt to do JSON.loads on JSON city. If you're not familiar with JSON.loads, it expects a JSON string, right? And it will, assuming the JSON string is well formatted, convert it into a Python dictionary. If it's not well formatted, it'll throw an exception. So if this works, then Python city should be a Python dictionary, and we should be able to iterate it over it like we do with any Python dictionary and see its keys and values. And it looks like we were able to do that with no problems. Okay, so if we just pause for a moment, what we can see is we're starting to explore structured data that can be used directly in downstream code. And furthermore, right, the only technique we've used so far to accomplish this is iterative prompt engineering techniques, right, that we've learned about earlier in the workshop. Okay, so in the spirit of iterative prompt engineering, now that we have kind of toyed around and iterated on a prompt and we feel like we have that prompt working, let's convert our prompt into a prompt template so we can parameterize out the city name. Okay, so here's the prompt that just worked for us with the city of Santa Clara. We're going to create a template from it, and we're going to use city name. We've gone back here to using from template because we're not specifying additional kinds of messages. We'll compose a simple chain out of this. We've got our parser and our chain, and if we invoke it again, with the city of Santa Clara, it seems to be working just fine. So just continuing to iterate on this from the ground up using simple techniques that you already know about, let's confirm that we can load the JSON object as a Python dictionary, and let's do this by augmenting our chain with a custom runnable to parse the model response directly into a Python dictionary. So if you remember, and to review, we're going to use runnable lambda here. We have a very simple function, so we're going to use a Python lambda function. It will expect a response. This is going to be the model response in our case, and we will return the result of calling json.loads on the model response's content property. We're going to call this parse to dict. Let's recompose our chain, or rather make a new chain that now ends by passing in the LLM response to our custom runnable parse to dict. And now if we invoke it, we can see that we have back, in fact, our Python dictionary. Okay, cool. So you know how to do this now using techniques that you are already aware at. But as a small improvement, rather than creating our own parser, we can use one that LangChain actually ships with. It's called Simple JSON Output Parser, which we're going to do here. This is in the same place, LangChain Core Output Parsers, as the str output parser, but we'll impart it here called Simple JSON Output Parser. It's just like with str output parser, there's more advanced things that we can do with this, but for our purposes, we're going to keep it simple. We'll invoke the output parser and get an instance, which we'll call JSON parser. We can now construct a chain using JSON parser, and you can see it behaves as expected. Okay, and as you can see in this notebook, we're kind of modeling again this iterative process that we often take when prompt engineering. We iterated on a prompt that worked for a single input. We created a template for that prompt that allows us to try it out on different inputs. Now that we have a nice chain, we would like to try it out on even more inputs. So we're going to define several different cities here: Santa Clara, Busan, Cairo, Perth, and we'll batch it into our chain to see how that goes. It looks like what we get back is good. And furthermore, our city details list, we can loop over it, and for each item, we're able to access items on each of the inner dictionaries and print them out with no problem. So this is good. Now, I want to call out a detail of something we've done here, right? Where we've used the large language model to create structure, but we're still continuing to leverage also the LLM's generative capabilities, right? So, since we've been using large language models to generate content throughout the workshop, this really might be obvious, but it really is worth highlighting. Not only are we using the LLM here as a means to structure the data that we provided it, but we're also combining this with its generative capabilities. So in the example we just worked through, our input data was the name of a city, right? And we used the LLM to structure this in a highly specific way into a JSON object. But more than just structuring the information we provided, namely the name of the city, we also used the generative capabilities of the model to extend the structured data with the country that the city was located in, which we ourselves did not actually provide, right? So this combination of generating structured output or data that has also been augmented with the generative capacity of an LLM is a really, really powerful set of techniques. So now, just using what we've done in this particular notebook, we have an exercise for you, which is to generate a Python list containing dictionaries that each contain details about the following books, all right? Each dictionary should have the book's title, its author, and the year of its original publication. And there'll be a solution below as well. One thing I'll say is that the techniques that we've covered in this notebook are effective, but also they're a little bit naive, and we're going to look at even better ways of doing this in the next couple of notebooks. So with that in mind, you should be able to accomplish this task, but don't worry too much about perfection at this point in time, all right? So yeah, give this a go, see if you can make it happen. Pause the video, and then after you've given this a go, come on back and we'll look at our solution to this problem together. All right, good luck. Okay, hopefully you were able to accomplish what you set out to do here. Let's take a look at our solution. Using a very similar approach to what we did above, we create a prompt template telling that we should make a JSON object representing the details of the following book, where we allow for the parameter of a book. We state that it should have fields for the title of the book, the author of the book, the year that it was originally published. And as we discovered through our iterative prompt engineering earlier, we reused the prompt to say only return the JSON, never return non-JSON text, including backtick wrappers around the JSON. We create a chain with this template, the LLM, as well as the instance of the simple JSON parser that we created earlier from LangChain. And now if we batch it, the sci-fi books, you can see we got back a Python list containing dictionaries that have a title, author, and year published for each of these years. Again, we ask you not to worry too much about perfection, and we're going to look at this more carefully in the next notebook, but if you see some interesting discrepancies in this list, good eye, but also don't worry about it for now. We're going to look at making this even better in the next notebook. All right, so in summary, in this notebook, you began approaching the technique of large language models generating structured output. And in the next notebook, we're going to drastically increase your capabilities to do this by using something called Pydantic, and more specifically Pydantic classes, together with something that LangChain provides called the JSON output parser. Okay, I'll see you in the next notebook.